Hi, class. This is a very brief introduction into object-oriented programming in C++. The main difference between procedural programming and object-oriented programming is the structure, the flow, really the very nature of it. Procedural programming that we may have seen in earlier coding experiences just start at the beginning, execute until it reaches some termination point, and then the program is done. Whereas object-oriented programming tends to be modular. It tends to have its components broken into easily managed entities, such as classes and implementations and separate function files. Object-oriented programming is also very popular because it is extensible. And this is one of the most dramatic features of object-oriented programming. You can take a class and simply extend it into some new application that is customized for whatever your application is. The other great thing about object-oriented programming is that it keeps the data separate from the implementation. That means data is hidden sort of behind a firewall by design, and only authorized methods are allowed through that firewall in order to directly manipulate the data. So if we were to take a look at just, well, what is object-oriented programming? It creates these things called objects. And an object is sort of a house that was built with a blueprint. Well, an object is an object that was created or instantiated from a class. The class is the definition, then the object is what we build based off of that definition. It's in object-oriented programming, an object is unique in that it's not just a collection of attributes like a struct. A struct will collect, say, for a student struct, it will collect some related variables, age, name, GPA, something like that. But with object-oriented programming, you can do that plus create significantly secure methods to go along with your private data. So any particular object can be split up into its data and its methods. And those methods are the ones by which, sort of like the APIs, the methods by which we go through to manipulate the data. Let's compare and contrast a struct with a class now. Here is a struct for a student again that just has three attributes or three variables, age, ID number, and last name. And again, we can bundle in any collection of attributes here and create variables from them. And then here inside our main function, we just simply create that student object, that student struct. And here we can directly assign a value to an attribute. stu1.age equals 21 is directly accessing this object's age attribute and providing it an assignment. That differs with object-oriented programming, and I'll explain why in a second. First, I'm going to fill out the class definition and show how it's very, very similar to the struct definition. Here's the class conversion of that, and it should look identical, and sure enough, it is. In its raw, pure form, a class is a struct and a struct is a class. However, we start to get into some major differences with structs when we start talking about access modifiers. What classification are these attributes and methods? And I'll address those here in just a little bit. Now, this concept of data hiding is a key part of object-oriented programming. And going back to that previous slide here, we see that since our data is being protected behind this firewall, that's the concept of data hiding, whereas only authorized methods and function calls can have access to that data. Let's go take a look at some live code and put this to an example. Here's our very first look at a class, and the specification for the class is always done up above the main function. In the next module and the next one after that, we'll see that it's often common to go ahead and split up a class implementation and its definition into different files, and we'll cover that. But for right now, we're just going to code these short, simple classes above main. So there is the class declaration student, and you'll note here that the student class ends in a semicolon. We have that somewhat rare syntax combination of a closing brace and a semicolon. And here is just where we define our private member variables. In the next video, we'll talk about public and private and what those mean with respect to object-oriented programming. We'll also talk about what all of these methods are here. But for now, just this is the essential setup. And when we call to instantiate an object, we just create it just like we would int counter or float total. This is just student Craig, just like a struct. Okay, pop into the next video and we'll look at more on these private member methods and functions and the setters and getters.